First, I would like to explain what is the degree in an equation. So for linear equations, so y is equal to 2x plus 3. The degree of a linear equation, so x is raised to the first power. It has 1 degree. It has a degree of 1. For quadratic equations, so y is equal to 4x squared plus 2x plus 9. So the highest exponent of the x is 2, so it has 2. It has a degree of 2. Now for example y, or we can change it to the function of x. For example, 5x to the 4th minus 3x squared plus 7. So the highest exponent here is 4, so this equation has a degree of 4. Now, equations with a degree of 3 or higher have more complicated curves than the one with 1 degree or 2 degrees. So for example, we have, so this is your x and y, your third degree equation would look like this, or sometimes it would be looking like this. So this is your x and y, or sometimes it would be doing like this and then going down again. So now these points, for example, this point, this is the tip. At the tip of this one, the slope for each point on this curve is changing, but at the uppermost tip of this one, the slope would be perfectly horizontal. Now the slope, if it is perfectly horizontal, the rise, the slope is rise over run. The rise at that point is 0. So whatever the number in here, it is the slope of this one is 0. Same case as at the bottom of this one. So this is the slope in here would also be exactly horizontal. So the slope of this one is also 0. So it's the same case with this one. This has a slope of 0. This one and this one, they will all have a slope of 0. Now, if it's like compared to the whole curve, like this is a high, these are called maxima, and these are called minima. So this in here, this is minima, and this is maxima. This is also maxima. In here, this is maxima, this one, and then this one is minima. So I'll give an example. So to get the maxima or minima of an equation, we can use the derivative. The derivative is the slope of the curve. So when you get the derivative of the equation, and then you equate it with 0, you will find the x points where the slope is 0. Now let us start with example 1. For example, we have the function x cubed minus 12x plus 1. So the first thing we need to do to find the maxima and minima is to find the derivative of this function. So the derivative is f prime of x. So we do the shortcut now, not the difference quotient. So this one goes down, this one becomes 3x to the 3 minus 1 is 2, so 3x squared minus, so 12x becomes 12 and 1 disappears. Now this one, since this is now the first derivative, we will equate this to 0 so that we will find the x where the slope, this is the slope, so we'll equate this slope to 0, so we will find the x value of the curve where the slope is 0. So if we equate it to 0, so we have 3x squared minus 12. We can factor out 3. So what we have is x squared minus 4 is equal to 0. So we can divide both sides by 0. So what we have is x squared minus 4. We can factor it out again. Is equal to 0. X plus 2, x minus 2. So this, because this is a difference of 2 squares, so I have factored it out to x plus 2, x minus 2. So if we equate it to 0, so we equate this to 0, x plus 2 equated to 0. So subtracting 2 on both sides, x is equal to negative 2. Now x minus 2 equals 0. We add 2 on both sides of the equation, you have x is equal to 2. So this is your minima and maxima. So we don't know what it is yet, so let's try to plot some points. I've plotted the first point. So what we do is we just assign a value to x, like 0. So we put the 0 onto x like this, 0 to the third power, 12 times 0 plus 1. So we get 0 minus 0 plus 1 is 1. So let's try to evaluate the function with x is equal to 2. So we write it like this. So 2 cubed, we follow this equation, 2 cubed minus 12 times 2 plus 1. That will give us negative 15. Negative 15. So if x is 2, y is negative 15. So we'll evaluate the other, we call this critical value because these are minima and maxima, we just don't know which one is yet. So if the function of x is negative 2, so negative 2 cubed minus 12 times negative 2 plus 1, just following still our equation, this would be negative 8 plus 24 plus 1, this would be 17. So if x is negative 2, your function of x is 17. So we just follow, we just put the values of x in here and then solve for the y. So I won't be showing you the rest of the computation. I'll just write the values that I have solved. Negative 15, 6 is 145, and negative 6 is negative 143. So if we plot this in here, 0 and 1, I have shortened the y-axis. This is the x-axis. I've shortened the y-axis so we can fit the numbers. So 0 and 1, so if x is 0, y is 1, it's in here. So this is, my graduation is 5, 10, 15, 20, 25, but the graduation here is 1, 2, 3, 4, 5, 6. And then 2 and then negative 15. So 2, so 1, 2, this is 2, but negative 15 will be around here. So 5, 10, 15, this is 2 and 15. So this is our first point. But if we have negative 2, your y is 17. So 5, 10, 15, slightly above 15. Wait, this is negative 2. This is negative 2. So this is your third point. This is first point, second point. Now if we put 4 4 is positive 17. 1, 2, 3, 4 is around above 15, same level as the other one. It would be this one. And then if it's negative 4, it's negative 15. So this is negative 4. Negative 15 is about here. Negative 4. 2 is negative 15. And negative 2 is 17. Okay, so slightly lower than that one. It's here. Negative 4 is negative 15 is in the bottom, sorry. So, and then 6 is 145. At 6, it will be really high up the scale. And then negative 6 is negative 143 is really below the scale. It's around this. So, if you trace the curve, it would appear like this. So from the bottom, from 6, it would be coming up in here, and then it should touch that one, so it should touch that one, and then go up again. So now, so the x is equal to 2 is this one. So this is your minima. This is minima. And then your x is equal to negative 2 is this one. This is your maxima. So this is your maxima. This is your minima. Now this is our second example. The function of x is equal to x to the fourth minus 8x squared. So first we have to get the derivative f prime of x. So we do the power rule, the shortcut, so it becomes 4x cubed minus 16x. Then we equate this to 0 so that we will know the value of x where the slope is 0. So this becomes 0. So 4x cubed minus 16x. We can factor out 4x. So what is left is x squared minus 4. Again, we can still factor this out. 4x is equal to x plus 2, x minus 2. And then if we equate 4x to 0, 4x is equal to 0, x is equal to 0. This is your first critical value. If you equate x plus 2 equal to 0, so transpose 2 into the other side, x is equal to negative 2. This is the second critical value. Could be a maxima or minima. And then the third one, x minus 2 is equal to 0. X is equal to 2. So this is your third value. So these are all critical values. So it could be either minima or maxima. Let's start with 0. If x is 0, so we plug in the value of 0 in x. So the function of fx at 0, 0 to the fourth minus 8 times 0 squared. So y is also 0. So if x is, let's say, if x is 1, so f is 1, we plug in the value of 1, 1 to the fourth minus 8, 1 squared. This is 1 minus 8, negative 7. So yeah, we just continue the computation, and what we will have in here is negative 1 is also negative 7, 2 is negative 16, negative 2 is also negative 16, 3 is equal to 9, negative 3 is also equal to 9, 4 is 128, negative 4 is still 128. So let's plot the values. If x is 0, y is 0, so it will be here. If x is 1, y is negative 7. So if x is 1, y is negative 7, it will be around, negative 7 is here. Yes. And then if x is negative 1, y is also negative 7, so it's here, it's symmetrical. If x is 2, y is negative 16. If x is 2, y is negative 16, it's in here. X is negative 2, y is also negative 16, it's around here. If x is 3, y is 9, 1, 2, 3, y is 9, it's around here. If x is negative 3, y is also 9, 1, 2, 3, it will be in here. If x is 4, 120 is way above, up there. If x is negative 4, it's also way above there. So the shape, following the points, the shape will be like this. Okay, so x is equal to negative 2 is this one, and then x is equal to 2 is this one. So these are both minima. And then the other one, x is equal to 0, is this one. So this is maxima, this is minima. Now, why do we need to study maxima and minima? Minima has an application not only in math, it has applications in physics, in business, economics, statistics. So yeah, there will be examples where we can use minima and maxima for solving other topics. If you have any questions, please feel free to give a comment, and I would like to know if my explanation is clear enough or not. Thank you.